Hi guys, in this particular lesson we shall learn about the pigeonhole principle. Now this particular principle is quite important when it comes to certain types of questions in logical reasoning. We shall be addressing some of these questions in this particular lesson. Also, the pigeonhole principle is quite important when it comes to the field of mathematics as well. We shall be discussing that too briefly. What is the reason why is it so important when it comes to the field of mathematics? So let's get straight to it. Right, so what is the definition that we have for the pigeonhole principle? Now the technical definition is in front of you. The pigeonhole principle states that if n items are put into m containers with n being greater than m, then at least one container must contain more than one item. Now if you haven't understood this already, let's look at this with the help of an example. Right, so in front of you what you can see is actually 12 different pigeonholes. So this is one pigeonhole. So what is a pigeonhole? Basically a pigeon can come and rest in a pigeonhole, right? And technically more than one pigeon can also go into one particular pigeonhole. Now what it so happens that there are 13 pigeons in a particular vicinity, and a storm comes in and they are looking for shelter. So what happens next is 12 pigeons, right, find their destination. So the 12 pigeons go in such a manner that they go in one pigeonhole each. Now there is a 13th pigeon. I told you the 13 pigeon, right? What happens to the 13th pigeon? Right? He has to go into one of these pigeonholes, isn't it? So for example, he might occupy the last pigeonhole. So we have two pigeons here in this particular pigeonhole. So according to the pigeonhole principle, we know that n items, now in this case there are 13 pigeons, 13 items that are put into m containers. In this case m will correspond to the number of pigeonholes, right? So in this case we can safely say that when n in this case is greater than m, right? So there are 13 pigeons and 12 pigeonholes. At least one container must contain more than one item. So that's what we see here. At least one container is containing more than one item, right? This might seem like a very simple concept, but think about it. So certain things like, for example, in India, right, say there are 3 billion people in India. Alright, I might be completely off the mark, forgive me if I am completely off the mark, that is. Say there are 3 billion people in India, and the highest number of hair strands on one's hair, highest number, the greatest number that it can go to is say 1,50,000, right? So in any hair that you find, you can't find more than 1,50,000 hairs. So is it safe to say that at least there are at least two people with the same number of hairs on the head in India? We definitely can say that. In fact, there are not at least two people, there'll be more than at least two people, right? We can safely say that there are at least 10 people with the same number of hair in India, right? I hope you got the understanding here why it kind of helps us with abstract concepts as well, such as this. Now moving on, we were looking at why this particular principle helps us with logical reasoning questions, right? Let's look at some of them and see how we can solve them as well. There's a drawer in a dark room which contains a large number of socks, all of which are among the colors red, black or blue. What is the minimum number of socks that should be picked in order to guarantee that there are at least two pairs of socks picked? Now, do understand that we have a large number of socks, and think of an infinite supply of red, blue and black socks, right? Now, we have to find out what is the minimum number of socks that should be picked in order to guarantee that there are at least two pairs of socks picked. Right, so how do we go about it? So think about this. If you start by, for example, think about it, you pick red, and red, right? This is the least number of pairs that you have to pick, right? So that it is possible that you have two pairs of socks. This makes it possible, but we have to guarantee it. Okay, when we go about guaranteeing it, just like we did in the previous case, this is basically pigeonhole principle all over again. When you have to guarantee it, you have to think in terms of the worst case scenario. What is the worst case scenario? We're trying to avoid this situation as much as possible. What situation? That there are at least two pairs of socks. We are keeping on picking socks, but we're trying to avoid this particular situation, right? So let's try doing that. Let's imagine that we start by, say, picking a red sock. Doesn't matter. Second sock you picked was a black one, third one was a blue one, right? So now whatever you pick, you got your first pair of socks, right? You have black as a pair. So at this point, think about what happens next. If you pick a red sock, then you are meeting this condition. If you pick a blue sock, also you're meeting this condition where you have at least two pairs of socks. So isn't it inevitable that when you pick five socks, it is guaranteed that you have two pairs of socks? Actually, that would be wrong. You still have an option where you pick a black sock, isn't it? Right? The worst case scenario is still not met. We The worst case scenario is when we pick another black sock, and now whatever sock we pick, be it red, black, or blue, will guarantee that there are at least two pairs of socks picked. So what is our count? For example, say it doesn't matter. So say I picked red. So the number we are looking for is six pairs of socks. So six socks rather. So you have to pick up six socks in order to guarantee yourself that you have at least two pairs of socks picked. Let's look at another question. 75 identical chocolates are distributed among 8 children. Find the maximum value for n for which the statement there is at least one child who gets at least n chocolates is sure to be true. Okay, so this is the very important part. I mean, this is the most important part of this particular question. This particular statement, there is at least one child who gets at least n chocolates. Okay, so what is that value for n is what we're looking at. Okay, so now if you're looking at 75 identical chocolates distributed among 8 children, right? So imagine these numbers represent the children who are to get the chocolates. We can give all 75 chocolates to one person, right? Which means there is at least one child who gets n chocolates. The value of n in this case will be equal to 75. But the problem here is that can we guarantee this? This is a possibility, right? Isn't this a possibility? Is it a guaranteed thing to happen? What could happen also is that everyone could get 10 chocolates each, such that so till the seventh child, everyone could get 10 chocolates, and the remaining 5 chocolates could go to number 8, right? The child number 8. So if that's the case, then we can't say that n is equal to 75. We can't say the maximum value for n is equal to 75, because there are worst case scenarios. There are other scenarios where there is a case where a child is getting lesser than n is equal to 75. So what could the answer be, and what is the approach that we have to take? So just like before, let's work out the worst case scenario. We have to distribute it in such a way that we are giving as little as possible to each and every child over here, right? So how do we go about doing that? We'll start by giving one each to every child, right? So once I give one each to every child, how many chocolates am I left with? 75 minus 8 chocolates. Similarly, I'll keep on doing that. I'll give one each and keep on doing that. Where do I reach eventually? The nearest multiple of 8, which is lesser than 75. So what is that number I'm looking for? I'm looking at the number 72, right? When you distribute 72 chocolates equally among people, the children over here, each of them will get 9 chocolates. So each of them get 9 chocolates each. So this is the maximum value of n, isn't it? So we can see that there is at least one child who gets at least n chocolates. So that value could be 9. But having said that, we still know that there are 3 more chocolates. 3 more chocolates that are remaining. Now what happens to these 3 chocolates? It has to go to one of these people, right? One of these children, isn't it? So just imagine after distributing 9 chocolates each, if we give one chocolate over here to one, we don't want to give him an extra chocolate because that's not the worst case scenario. The worst case scenario is when we're trying to minimize the number of chocolates that each of them are getting. So for example, if the remaining 3 chocolates are distributed in this manner, we can for sure say that at least one kid has what? Has 10 chocolates. The maximum value of n, right, where it is guaranteed to be true, right? It is sure to be true or guaranteed to be true is 10. So this is the answer that we are looking